This is a recording for Edexcel Further Pure 1, Coordinate Systems 1, the Parabola and Rectangular Hyperbola. Section 1.3, Cartesian and Parametric Equations for the Parabola. We saw in a previous video that the parabola is one of four conic sections: the circle, ellipse, parabola and hyperbola. The parabola itself is one where the plane that is cutting the cone is parallel to the side of the cone. That then produces an open curve, but it only has one branch. The standard Cartesian equation for a parabola is y squared equals 4ax, and that produces a parabola looking like the one we have below here on the graph. You'll notice that this is, as it were, on its side compared to the parabolas that you have met already. So y squared equals 4ax is this way, whereas y is equal to x squared, is the parabola you have met before, is a parabola which is upright. But they're both the same shape curve, they're just in a different orientation. You'll see here we've got y is a function with x squared in it, and here we've got y squared is a function of x. The a in here depends on the value of a, what the curve looks like. So I've got a program now just to have a look at that in a little bit more detail. So here's the parabola y squared is equal to 4x. In other words, we've got the value of a here equal to 1. Now this slider allows me to change that value and look at what happens to the curve. So what I'm going to do first of all is to increase a, and you can see that what's happening is it's getting wider, it's opening up. And so there we've got y squared is now 3 multiplied by 4, or 4 times 3 rather, giving us 12x. Coming back down again, it's going to get narrower and narrower. We go past 1, we can get into fractional values. So and then at 0, what do we get? Well, there we've got y squared is equal to 0. In other words, it's just a straight line, not actually a parabola as such now. So a has to have some value. If we go to the negative part, then the parabola is pointing to the left, or the open part of it is pointing to the left, but it's the same shape of curve. So different values of a are going to give us different slopes to the curve itself, but they're all part of this family of parabolas. Well, for the parametric equation of the parabola, we're looking for two separate equations, one for x in terms of a parameter t, and another one for y in terms of the same parameter t. And what we're trying to do is to decide, if we choose a particular parameter for x, what would that then make y? Well, if y squared is equal to 4ax, the easiest thing to do is to choose something on the right hand side here which makes the right hand side a perfect square. And to do that, if I let x be equal to at squared, then that produces y squared is equal to 4a multiplied by at squared. In other words, it's 4a squared t squared. But that's just equal to 2at all squared. And therefore, y will be equal to 2at. So my parametric equations are x is equal to at squared, y is equal to 2at. So we are just looking at that again. If x equals at squared, then y is equal to 2at. So we say that the parametric equations are x equals at squared, y equals 2at. So this general point here, p, which is xy if we're using these Cartesian values, is then given by at squared 2at in its parametric form. so that for different values of t, that point will move around the curve. So what is important then is that you remember these two forms, y squared equals 4ax, and the parametric equations x equals at squared and y equals 2at. So that when you're asked a question like this, which says here we have a Cartesian equation y squared equals 10x, what are the Cartesian equations? Then we can say, well, the general form is y squared equals 4ax, and therefore that gives us that 10x must be equal to 4ax. So in other words, a is equal to 2.5. So we know the value of a. The parametric equations are x is equal to at squared, and therefore we get that x is equal to 2.5 t squared, and y is equal to 2at. So that means that y is equal to 5t. So here it is, neatly written out. So it's just a matter of working from our standard equation to work out the value of a, and then substituting that into the two parametric equations for x and y. This question is the other way around. This time we've got the parametric equations, x equals 5t squared and y equals 10t, and we're asked to find the Cartesian equation. We've already looked at one method of doing this, which is one of substitution and eliminating t. So we could look at that first of all. If y is equal to 10t, then that means that t must be equal to y over 10. So we can now substitute that into x to give 5, and then y over 10 all squared. So that's y squared over 100. So when we multiply by 5, that's equal to y squared over 20. And therefore we have in its standard form the Cartesian equation is y squared is equal to 20x. That's one way that we could do it. The other way is to say, well, if y is equal to 10t, we know that the standard parametric equation y equals 2at, and those two things, comparing them, implies that a must be equal to 5. The Cartesian equation is y is equal to, so y squared is equal to 4ax, and therefore if a is equal to 5, y squared is equal to 20x. So there are those two methods written out for you. It doesn't matter which you use, either of them is satisfactory. Both of course lead to a Cartesian equation, y squared is equal to 20x. Well, that's the end of this particular recording, and in the next one we'll be looking at what are called the focus directrix properties of the parabola.